This is a prism via which dispersion of light is happening. The violet light has a greater refractive index and hence it's deviated the maximum. Red light has least amount of refractive index in the visible spectrum and hence is deviated the least. Now let us try to analyze the angle or angles via which the light is getting deviated. So light was traveling straight in this particular direction and then the red light got deviated in this direction and the violet light got deviated the maximum, which is in this direction. So if we extend these two lines, then we get the angular spread. So we can say that this is the angular spread of the light. Now this angular spread is called as angular dispersion. It is very easy to figure out that this is the deviation of violet light. So this I can say is delta violet and this is the deviation of red light. So this I can say is delta red. The angular spread called as angular dispersion theta. So this particular angle theta angular. So this is angular dispersion. So angular dispersion is going to be given as delta of violet minus delta of red. So it's deviation of violet minus deviation of red. We consider the yellow light to be towards the center of the spectrum and hence the deviation of yellow light is considered to be the average deviation. So let us say this is the yellow ray, that the deviation of the yellow ray of light is going to be considered as the average deviation, that is delta yellow. Now if we want to find out the angular dispersion with respect to the average dispersion, then we define something called as the dispersive power omega. So omega is delta V minus delta R compared to the mean deviation or average deviation, which is delta yellow. In case of thin prisms, we know that delta is given as A into mu minus 1. So this is in case of thin prisms. And thus for thin prisms, delta of violet will be A into mu violet minus 1. And delta of red is going to be equal to A into mu red minus 1. Similarly, delta of yellow will be equal to A into mu yellow minus 1. So, understanding all these quantities, for thin prisms, the angular dispersion theta will be given as delta violet minus delta red, that is A into mu violet minus mu red, mu being the refractive index of violet and red light respectively. And omega for thin prisms is going to be given as A into mu violet minus mu red upon delta yellow is A into mu yellow minus 1. So that means omega will be equal to mu violet minus mu red upon mu yellow minus 1. So this is valid for thin prisms. These two formulae are valid for thin prisms.